This video is about factoring a sum of two cubes, and here's the formula we're going to use. A cubed plus b cubed, that would be the sum of two cubes. And on the right side you'll see its factored form. And so we're going to apply this formula to a few examples. We'll start with one that's relatively simple. How about x cubed plus 27? And so if this is a sum of two cubes, then we should be able to write it as something cubed plus something cubed. And we can, because x cubed is x cubed and 3 cubed is 27. And so if you can match this up to the formula above, you can see that x is kind of like the a up here, and 3 is kind of like the b. And so all we're going to do is write the right side of this formula, except wherever we see a, we're going to write x, and wherever we see b, we're going to write 3. So here we go. We'll have x plus 3 as in a plus b, and then x squared minus 3x plus 3 squared, which is actually 9. This is the a squared plus ab, usually you write the number before the variable, plus b squared. And there it is in factored form. Now let's do another example. This time let's say we had 56 x y squared z cubed plus 7 x y squared w to the 6th. Alright, so this one's a little more complicated looking. In fact, right away it doesn't look to be a sum of two cubes because nothing cubed is 7. However, there is a greatest common factor that can be taken out of both of these, which would be 7 xy squared. So, as usual, we should always do that first one factoring, and if we do, we'll end up with 8 z cubed plus w to the 6th. Okay, so again, if you distributed the 7xy squared back through these two terms, you should get the original. So we just took out the GCF. And what we have left in here is a sum of two cubes because, as we can see now, both of these terms can be written as something cubed. And that's the goal if it's going to be matched up as a sum of two cubes. So in fact, 2z cubed is 8z cubed, and then w squared cubed is w to the 6th, because again you'd multiply exponents in this case. Alright, so now we have this matching up to the left side of the formula where 2z is our a and w squared is our b. So now we're going to go with the right side, but we have to make sure our GCF stays out front, 7xy squared. So here we go, we have 2z plus w squared times 2z squared, that's in parentheses, 2z squared, that's like our a squared part up here, minus 2z times w squared plus w squared squared, kind of like the b squared up here. Okay, so the last step is just to simplify these factors in terms over here with the exponents. So we'll make this 7xy squared times 2z plus w squared times, now using exponent rules, 4z squared minus 2zw squared plus w to the 4th. And now we are in final factored form. And lastly, one more example for a sum of two cubes. Let's suppose we had x plus y cubed plus 8. Alright, well this one looks different than the previous two examples because of this binomial that's being cubed here. And so we're still going to match it up and realize that this is like our a, and of course 8 will turn into our b term. Let's rewrite this one more time as x plus y cubed plus 2 cubed. Okay, so now we can see clearly that that's a and this is b if you're comparing it back up to this original formula. So now if I just write out the right side of that formula using these a and b's, I'll have x plus y plus 2, that's like a plus b, and then a squared for us here would be x plus y squared, minus a times b would be 2 times x plus y, again just writing the number first, plus b squared would be 2 squared. And so now let's simplify once more. This would be x plus y plus 2 times, now we're going to have to FOIL out this binomial since it is being squared, alright, which would turn this into x squared plus 2xy plus y squared. And then we'll continue distributing the negative 2 as negative 2x minus 2y plus 4. Now we have no like terms to combine, so this is in final factored form. And that's factoring a sum of two cubes.